Again, hi everyone. This would be the last part of our video lesson about the conic section circles. So let us start. On this part 3, we will define what is the general equation and we will use the different properties again of the circle. Suppose we expand all the binomial terms on the given standard equation of a circle. What do you think will happen to the equation of our circle? So I'll give you time to think. So what do you think is the process or what will happen to the equation from coming from a standard equation? From one equation, which is the standard equation, we will form the general equation. And what is the format of the general equation of a circle? For that, let us define what is the difference between a standard equation and the general equation. When we say standard equation, it provides us a clearer insights into the properties, characteristics of a specific conic section. So we started with the circle. We have remaining three conic section. So we have different standard equation in each of our conic section. This gives us insight what are the characteristics, how do we graph, what are the different values of their properties, while the general equation provides us a unified representation of all these conic section cases. Meaning, if we are talking about the general equation, we cannot identify first what is the specific conic section that is given. Unlike a standard equation, you can see that this equation is good only for the circle. This equation, another equation, is only good for the remaining three such as parabola, hyperbola, and even the ellipse. So what is the format of our general equation? The format of the general equation is given by the quantity of ax squared plus by squared plus dx plus ey plus f is equal to 0, where for the circle, a and b are equal, sorry, equal, but a and b cannot be equal to 0. Again, for your circle, the values of a and b should be equal. A and b are not equal to 0. So a, these variables a, b, d, e, and f are constant or coefficient. There are values for that. But for the variables x, y, x squared, y squared, that are your variables. So let us try one example. Suppose we expand the standard equation of a circle whose center is at -3, -1 with the radius of square root of 6. From the previous lessons or video presentations, we have identified already the standard equation of this given properties. So the standard equation is given by x plus 3 quantity squared plus y plus 1 quantity squared is equal to 6. Okay? Let us expand and transform this given standard equation into the format of a general one. Rewriting the standard equation, we have the quantity of x plus 3 squared plus the quantity of y plus 1 squared is equal to 6. When we say expand, mga anak, no? So when we say expand, we will use the different techniques that you have studied and we have recalled from previous lessons during your junior high school, such as the binomial expansion, FOIL method, and other related terms. So we have x plus 3 quantity squared. So if we expand x plus 3 using the special products, the binomial expansion, and even the FOIL method, it will result into the quantity of x squared plus 6x plus 9 plus y squared plus 2y plus 1 is equal to 6. Our goal is to attain the format of ax squared plus by squared plus dx plus ey plus f is equal to 0. There are certain terms that are needed to be simplified. So let us format first equal to 0. The constant 6 on the right side of our equation, this one, should be transposed together with other terms. But let us arrange first the given equation. In the highest exponent of the variable, starting with the variable x, going to the smallest, which is a constant. So we have step B, we have x squared, then you copy y squared, and then 6x and 2y are copied afterward. 6x plus 2y are copied. Then we can see that this is your ax squared, these are your by squared, dx, and ey. Right? And then, lastly, there are constant term remaining. Plus 9 plus 1 and 6 from positive will become negative 6 is equal to 0. I will erase this part first. We can further simplify our constant term. We have x squared plus y squared plus 6x plus 2y plus 9 plus 1 is 10 minus 6. So the answer is 4 is equal to 0. And this is already your general equation. Again, we will encounter the same problem on the next conic section with the same format, but different values of A, B, D, E, and F. Okay? Proceeding to our main topic, on the next slide, we need to identify, again, the center and the radius. So, we are given the center and the radius of the given equation in general format, x squared plus y squared plus 4x minus 6y plus 3 is equal to 0. So, what is the first thing we need to do? The first thing we need to know is how do we transform the given general equation into a standard format. So we have already discussed on the previous slide how to transform a general equation into, how to transform a standard equation into a general one. And for now, we will transform the given equation in general format of number 1, x squared plus y squared plus 4x minus 6y plus 3 is equal to 0 into standard 1 before we get the value or the coordinates of the center and the length of our radius. Again, you need to recall the process of completing the squares. So, on the previous meetings that we have, you have to do the process of completing the squares. But this time, you have the variable x and the variable y. You still need to follow the process. First is you check if the constant or the coefficient of x squared and y squared is equal to 1. Based on the given, x squared and y squared has a coefficient of 1. So no need to divide by a number all of our given. So first, x squared, y squared are already has a coefficient of 1. Doing the second step, number 2 or letter A, we need to isolate the constant and group the terms with the same variable. X squared and 4x are grouped together. Plus, okay, don't forget plus in the middle. We have y squared minus 6y is equal to negative 3. So, si negative 3, isolate na natin yan. Isolate negative 3 on the right side. Continuing to the process of completing the squares, we need to divide the coefficient of the variable x and the variable y. In these cases, I will put a label or a variable representing the solution for the variable x and the variable y. It will be represented by the variable c sub x for the variable x and c sub y for the variable y. Identifying the constant or the coefficient of the variable x, it is positive 4 and negative 6 for y. According to the rule or the steps in the process of completing the squares, we need to get half of that constant and square it afterwards. So 4, half, then square it with the same process, half, then square it again. Then 4 divided by 2 is 2 squared, and negative 6 divided by 2 is 3 negative squared. Again, simplify. 2 squared is positive 4 and 3 squared is positive 9. So what happened to these two values? So these two values of c sub x and c sub y should be added into the respective variable. So your next step, letter C, is x squared plus 4x plus 4 plus y squared minus 6y plus 9 is equal to negative 3. But we are not yet done on this process. According to the rules of properties of inequality, or equality rather, whatever you have done to the left side should be done on the left side. Since we added 4 and 9 from the left side and right side, we should also add them to the right side. So we will have plus 4 and plus 9. Continuing to the next step, we can now simplify the right side and we can factor out the left side. Since this is the format of a special or rather perfect square trinomial, you recall what is the pattern that we are using for this one. Since 4x is positive, it can be factored in the format of x plus 2 quantity squared and also y minus 3 quantity squared is equal to negative 3 plus 4 plus 9 is equal to 10. And this is already your standard equation. But remember, our problem pertains to finding the coordinates of the center. So our coordinates of the center, again, recall on the previous lesson, previous video, that we will not solve already for the coordinates of the center, but rather, we will apply the additive inverse. Since positive, the sign of 2 inside the equation is positive, and getting the additive inverse is, it will become negative 2, additive inverse of negative 3, it will become positive 3, and this is already your coordinates of the center. And for the radius, if r squared is equal to 10, just getting the square root of both sides, the value of our r, or the length of our radius, is equal to the square root of 10 units. And that is already your final answer. Again, remember, if the given equation is in general format, first is to transform it into standard equation using the process of completing the squares before you apply the additive inverse and getting the square root of r squared on the standard equation. Next example, number 2. Identify the center and the radius of the circle defined by the equation x squared plus y squared plus 2x plus 2y minus 7 is equal to 0. Again, let us rewrite the given general equation into the next slide. Equation x squared plus y squared plus 2x plus 2y minus 7 is equal to 0. Follow the step. Identify if the coefficient of x squared and y squared are equal to 1. In this case, number 2, we have the same process as number 1. The coefficient of x squared and y squared are equal to 1. We can now proceed in isolating the constant 7 and group the terms with the same variable. Okay, you have x squared plus 2x plus y squared plus 2y is equal to positive 7. Doing step B, we need to solve for the value of our c sub x and c sub y, which are respectively getting the constant of the variable x and variable y. And the constant of variable x and variable y are both 2. So get half of it, then square it afterwards. Get half of y, then square it afterwards. So 2 divided by 2 is positive 1 squared, and same with y. And the answer would are positive 1 and positive 1 for the y. Continuing to the next process, step C, this one, constant 1, should be added for the respective variable and the same with the right side. So you will have x squared plus 2x plus 1 plus y squared plus 2y plus 1 is equal to 7 plus 1 plus 1. Okay. Continuing on step letter D, since we already have a perfect square trinomial for x and y, we can now factor out. And the factors are x plus 1 squared and y plus 1 squared is equal to 7 plus 1 is 9. We can now identify our coordinates of the center and the length of the radius. For the coordinates of the center, again, get the additive inverse from the standard equation, and the coordinates of the center will be negative 1, comma negative 1. And for the radius, which is r squared, is equal to 9, get the square root of both sides. R is equal to positive 3 units. Continuing to example number 3. For example number 3, we have to identify the radius of the circle defined by the equation 2x squared plus 2y squared minus 17x is equal to 0. This time, as you can see on the given equation, there is a constant in front of the x squared and y squared variable. So we need to do an extra step in solving the standard equation first. So writing the general equation on the next slide, we have an equation of the format 2x squared plus 2y squared minus 17x is equal to 0. First is, let us identify this time if x squared and y squared coefficient are 1. But in this case, it is not. So we will apply, or we need to make them equal to 1, or the coefficient should be equal to 1. What we will do is, we will divide the whole equation, or each term of the equation, by the coefficient 2, or the constant 2. So let us divide the whole equation for our step A. So 2x squared plus 2y squared minus 17x is equal to 0. So if we divide both sides, all of the equation by 2, you will simplify it and you will have an equation of x squared plus y squared minus 17 over 2x is equal to 0. For your step B, we need to isolate the constant. But by looking at the simplified format from the general equation, there are no constant. And the next thing to do is to group all the terms with the same variable. That's the next step. Let us group x squared minus 17 over 2x and y squared is alone on the next step. Okay? This time, your letter C step is to solve for the value of your c sub x only. Why c sub x only? Because, as you can see here, there are no terms together with y squared. Kaya mag-isa lang si c sub x ang isosolve natin. So, instead of writing in this format, negative 17 over 2 over 2 quantity squared, we have a complex fraction. So instead of dividing it by 2, it is the same process as multiplying 17 over 2 by 1/2. It's the same. The answer will be the same. So be careful in typing on your calculator. And negative 17 over 2 times 1/2 is just negative 17 over 4 squared. Okay? So, please be careful on using your calculators or solving fractions, especially if you are not familiar with the calculator you are using. So, be careful mga anak. So, this c sub x should be added from the left side and the right side. Remember, this is only for the variable x. So, on our step D, we have x squared minus 17 over 2x plus, get the squared of 17 over 4 first before you add them. So the answer would be 289 over 16. So that would be 289 over 16 plus y squared is equal to, remember this is 0 plus 289 over 16. So factor out. Letter D. I will show you a technique if you are having a hard time in factoring. Go back to step letter C. This value is always the factor of the next step. Remember, you only squared 17 over 4. So if you factored this out, that should be the binomial of x minus 17 over 4 quantity squared plus y squared is equal to 289 over 16. And this is already your standard equation. For the standard equation, we can now solve or get the center coordinates and the length of our radius. Getting the additive inverse for h and k, the value for h is 17 over 4. It becomes positive, so that would be 17 over 4 positive, additive inverse. And since si y squared ay mag-isa, he is alone, or it is alone, so therefore, we can now get the value of our k, which is equal to 0. So wala naman tayong nakikitang ibang value, kaya 0 na po yun automatically. And then for our r squared, it is equal to 289 over 16. Get the square root. So therefore, our radius is equal to 17 over 17 over 4 units. You can write it into decimal format as long as it is in 4 decimal places. Okay? Next example would be, we will use an example of a graph. Next example, we have this illustration. Find the general equation of the circle illustrated. So you need to identify first the general equation. But before that, you need to get what are the properties that are very useful in this scenario. In this scenario, we can see the center of our circle. And the coordinates of the center of our circle is given by 4 as your h, and your k is 2. And by simply counting the units from the center to the edge of our circle, we can identify the radius by counting 1, 2, 3 units. No need to solve for the distance formula. No need to solve for other parts of the circle. So we already have the coordinates of our center, which is 4, 2, and the length of our radius, which is 3 units. Going to the next slide. Center again, 4, 2. Radius is 3 units. We need to identify the general equation. For the general equation, we will write first the standard one. Standard one is x minus h squared plus y minus k squared is equal to r squared. H is 4, so it will become x minus 4 squared plus y minus 2 squared is equal to 3 squared. Continuing to the next step, expand the binomial using binomial expansion, FOIL method, special product. So it will become x squared minus 8x plus 16 plus y squared minus 4y plus 4 is equal to 9. You can now arrange all the terms from highest exponent to the lowest, and you can transpose the constant 9 to the left side. So it will become x squared plus y squared minus 8x minus 4y plus 16 plus 4. From positive 9, it will become negative 9 is equal to 0. Simplifying the constant terms, so it will become x squared plus y squared minus 8x minus 4y plus 16 plus 4 is 20 minus 9, that would be 11 is equal to 0. Still, we can see the format of our general equation. Minus 4y plus 11 is equal to 0. So ax squared plus by squared plus dx plus ey plus f is equal to 0. So this is already your general equation.